All right. So in this next one, we have a fact that you may not have known before, but radio stations have their numbers, their call signs, set because of their broadcasting frequency. So, if 97.5 is a radio station, they broadcast 97.5 megahertz. So this one with random numbers, 104.9 megahertz, the station would be called 104.9. We can use this as a frequency. So megahertz just means lots and lots of hertz. That's a frequency to go back and find wavelength. So going back to when we were talking about sound waves and waves in the ocean from the earlier problem set, we can put this information together. What's going to happen now, because radio waves are a form of electromagnetic radiation, they actually propagate or move at the speed of light. So lambda, similar to a formula we saw before, instead of being v over frequency, is going to be c over frequency, just to show that it's the special speed of the speed of light. Okay, so going in and plugging in some numbers here, c is a constant, 3 times 10 to the 8 meters per second, and then the frequency here, 104.9 megahertz, means times 10 to the 6 hertz, so it means millions of hertz. Hertz, you also want to remember, means per second, so that's going to cancel the per second part there, and that's where our meters come from. So now we want to take and divide these two, and as it turns out, we get about 2.86 meters. So about like 9 or 10 feet is the wavelength of what this radio station would be, which I always thought was kind of an interesting fact.